Hey there, guys. This next lesson, we're going to look at absolute value inequalities. And so that's going to combine what we know about absolute value equations with what we've been doing with multi-step and compound inequalities. So for absolute value inequalities, you have two different cases. The first case would be inequalities that involve a greater than or equal to sign, assuming that the absolute value is isolated and on the left side of the equation. So let's imagine we had a really simple absolute value inequality that said the absolute value of x is greater than or equal to 7. Well, if this is the case, then there are two possibilities for x. Either x can be greater than or equal to 7, or x can be less than or equal to -7. Okay, if you think about all of the numbers that are -7 or smaller, if I put them into an absolute value bar, the absolute value of those numbers is going to be larger than 7. So that's why we have those two cases there. So the graph for that inequality would look like this. We would have a solid dot on -7, and everything to the left would be shaded. And then we would have a solid dot on +7, and everything to the right would be shaded. The interval notation for that would be -infinity to -7 with a closed bracket, unioned with +7 to +infinity, again with a closed bracket on the 7. So you can see from looking at this graph and looking at our interval notation that this graph's an OR inequality. And so that's true of all absolute value inequalities that have this format. If you have a greater than or equal to at the end, once you have the absolute value isolated, that is going to represent an OR compound inequality. Now let's take a look at less than or equal to. That's case 2. So if I had the absolute value inequality, absolute value of x is less than or equal to 4. Well, there are two possibilities for x then. X itself could be less than or equal to 4, or x could be greater than or equal to -4. Okay, if I put values that are greater than -4, like -3, -2, inside the absolute value bars here and take the absolute value of those, okay, those numbers would be smaller than 4 up until you get to +4. So the graph of that would look like this. We would have a solid dot on -4, shading everything to the right, also a solid dot on +4, shading everything to the left. And so this would be all the values in the middle between those 2 points there. The interval notation would be all values from -4 to 4. So this is an example of an AND compound inequality. Okay, so less than or equal to absolute inequality symbols and an absolute value inequality produce AND graphs. And so what all this means is simply that absolute value inequalities are compound inequalities too. So if you know how to solve absolute value equations and you know how to solve compound inequalities, then you should be able to solve absolute value inequalities. So here are the 4 basic steps to solving those. Step 1, just like equations, we isolate the absolute value expression first. Our second step is to create 2 cases, just like equations. We're going to use what I call the KISS method to do that, and that stands for keep it, switch, switch, and I'll explain what that means here in the first example. After that, you solve both of your inequalities, and then we graph on the number line and put our answer in the interval notation we know how to do. So look at number 1. We have the absolute value of 2v minus 3 is less than 19. Step 1 is done for us. This is already isolated, the absolute value expression. So I'm going to set up my 2 cases now in step 2. So my first case is just going to be 2v minus 3 is less than 19. I'm keeping my inequality symbol the same. Okay, that's the keep it part of this KISS method up here that I was referring to. My second case is going to be to take 2v minus 3, to switch my inequality symbol from a less than to a greater than. That's the first switch in the KISS method. And then also to switch my 19 to a -19, okay, which is the second switch. So we keep the inequality here, we switch here, and we switch the sign here. That's what that keep it switch refers to. So now when I solve both of these inequalities, I'll add 3 to both sides for the left one to get 2v is less than 22. Divide by 2, I get v is less than 11. Over here, I'll add 3 to both sides. That will give me 2v is greater than negative 16. Divide by 2, I get v is greater than negative 8. Okay, you have to ask yourself, what kind of compound inequality is this? Well, because when our absolute value was isolated, we had a less than symbol. It is like the second case up here when we have the less than or equal to's. This is going to give us an and compound inequality. So we're going to put a open dot on positive 11 and an open dot on negative 8. And everything in between those two endpoints will be shaded. So this is what the graph looks like. Interval notation, the minimum value again is negative 8. The maximum value is positive 11. And I'm going to close with parentheses on both sides because these are both open hollow dots. Okay, number 2, we have the absolute value of 7 minus 4n is less than 27. So again, my absolute value is isolated, so I'll write my two cases. 7 minus 4n is less than 27. Keeping my inequality symbol here the same, and then my second inequality will be 7 minus 4n. Switch the inequality symbol and switch the sign on the 27. Solving both of these, we'll subtract 7 from both sides. This gives me negative 4n is less than 20. I'm dividing by negative 4, so that's going to switch my inequality symbol here to n is greater than negative 5. My second inequality, again, subtract 7 from both sides. I get negative 4n is greater than negative 34. And then dividing both sides by negative 4 again, my inequality symbol switches to a less than on the right. And negative 34 divided by negative 4 is going to be a positive 8.5. Again, we're looking at the inequality symbol here to determine is this an and or an or. A less than here tells us this is going to be an and inequality. So I'm putting an open dot on negative 5 and an open dot on 8.5, which should be about right here. My shading is going in the middle. And the interval notation will look like this. Parentheses around both ends. Okay, looking at the back side, number 3, we have the absolute value of q minus 1 all divided by 4 is greater than or equal to 2. So the first thing I need to do for this inequality is to isolate the absolute value expression. So I'm going to multiply by 4 on both sides. And that's going to give me the absolute value of q minus 1 is greater than or equal to 8. From there, I'll write my two cases. My first case will just be q minus 1, keep the inequality sign greater than or equal to 8. My second case will be q minus 1, switch the inequality sign and switch the sign on the 8, less than or equal to negative 8. To solve these, I just need to add 1 to both sides. So here I get q is greater than or equal to 9. Over here I get q is less than or equal to negative 7. When you look at your inequality sign, you need to look at the inequality sign when the absolute value expression was isolated. So that's this step right here. I have a greater than or equal to. Greater than or equal to is an or case, so this is an or compound inequality. So I'm going to have a solid dot on positive 9, and we're going to the right, greater than positive 9. I'll have another solid dot on negative 7, and we're going to the left, all the values less than negative 7. So the interval notation will look like this. Using a bracket to close both my negative 7 and my positive 9. Okay, what I'd like you to do now is pause the video, and I want you to try number 4 on your own. Once you think you have an answer for that one, click play to check. Okay, for number 4, this should be your interval notation and your graph. It's an or inequality because of this greater than or equal to here in this step. So you have all of the k values less than or equal to -5, or all of the k values greater than or equal to +11. 2 more we're going to try. Number 5, I need to isolate, again, my absolute value first in this inequality, and I'm going to do that by first adding 1 to both sides. Again, this -4 here is being multiplied by the absolute value, so we'll save that for our next step. We need to get rid of this -1 though first. So this gives us -4 times the absolute value of x plus 9 is less than or equal to -20. Then I can divide both sides by the -4, and I get the absolute value of x plus 9. Dividing by a negative switches my inequality sign, so it becomes a greater than or equal to +5. Okay, this is why it's really important to look at the step where your absolute value is isolated when you figure out what kind of compound inequality it is, because notice that I switched from my original problem, a less than or equal to a greater than or equal to in this step. So this means that in my answer, this is going to be an or inequality. Okay, we go by this step right here, and this is an or inequality. Our 2 cases will be x plus 9 greater than or equal to 5, or x plus 9, switch this and switch that, less than or equal to -5. So I subtract 9. For the left case, I get x is greater than or equal to -4, and when I subtract 9 on the right case, I get x is less than or equal to -14. So I'll have a closed dot on -4. My shading will go to the right, and another closed dot on -14. My shading there will go to the left. The interval notation will look like this. And we're using, again, brackets for both the -14 and the -4. Okay, one last inequality, number 6. I again want you to pause the video and try this one on your own. Once you have your answer, click play to check that. Okay, for number 6, this should be what your inequality looks like. So it should be an and inequality. You should have all the values between -4 and +10. If you had any questions over what you saw in this video, be sure to ask those the next time I see you in class. And until then, folks, have a nice day. You're all wonderful people. Take care.